Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having the good time, people. You can first of all let me know in the chat box if I'm audible and visible to everyone, right? Just let me know in the chat box if I'm audible and visible to everyone. Just a second, there is some strange light coming on the screen, yeah? Just people give me a second. Okay, so hello Salman, hi Anand, hi Rana, hello Kanishka, hello Manisha, hello Ashwarya, hello Jency, hello Amir, hello Subha, hi Hike, hello Salman. Welcome back everyone, welcome back. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not, yeah? Let me know people fast, let me know fast. Perfect. So good evening everyone, good evening, welcome back to your JEE Enthuse, right? So as you all must be knowing, tonight it's going to be our 18th mock test for the JEE 2021, right? And before starting the session, people, the ones who are new to the channel, right, let me introduce myself. My name is Wassim Bhatt and I'm your chemistry master teacher writer on this JEE Enthuse channel, okay? And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yes? So people, am I perfectly audible and visible to you? Because I'm seeing someone is, Akida is saying it's a bit lagging, right? So just let me know in the chat box, is it perfectly okay? Is it perfectly okay, people? Yes? All right. Okay, so the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yes? Perfect? All right, people. So let me know in the chat box if you guys are super duper excited about the session. Let me know in the chat box if you people are super duper excited about the session, right? Let me know people fast in the chat box. Let me know fast. Well, it's going to be our 18th mock test for your JEE 2021. Yes? Well, I can see a lot of fire symbols are coming up. That's wonderful. So people, without wasting a lot of time, let's get started with the rank booster JEE 2021 complete chemistry mock test number 18 over here, right? So let's get going, let's get started with the first question, which is going to be on your screen in 3, 2, 1, and now. This is the question on your screen. The question is from your NTA, okay? Give it a try and let me know its answer in the chat box. Ionization energy first and ionization energy second of few elements are given below. Which of these would be an alkali metal? Okay, a very simple question this is. Yes, Joy, I know it. I'll take it out afterwards. People, give it a try. Let me know its answer fast. It's a very simple question, right? Yes. What do I need to check basically? Look at the question carefully, guys. Look at the question carefully. First ionization energy and the second ionization energy of few elements are given below, right? I'm given with the first and the second ionization energies of certain elements. Which of these would be an alkali metal, right? Alkali metals, as you all must be knowing, these are your group first elements, right? Your lithium, sodium, potassium, rubidium, cesium, right? Lithium, sodium, potassium, rubidium, cesium, these are group first elements. What is their general outermost configuration? Their general outermost configuration, as you all must be knowing, it's NS1, right? Okay, let me take one element out of it. For example, I'm talking about sodium. Correct? What is the configuration of sodium? As you all must be knowing, it's 1s2, 2s2, 2p6, 3s1, right? Okay, let's say this sodium is right now in isolated gaseous form. It is an isolated gaseous form right now, for example, yeah? Now people, the amount of energy which we need to supply in order to remove this outermost electron is something which I'll be calling as ionization energy first, And as you all must be knowing, the first ionization energy of all the group first element is very, very less, right? Because group first elements, they have got just one electron in their outermost shell. They easily lose this outermost electron, right? So I can say the first ionization energy for group first elements will be very, very less. But talking about the second ionization energy, in order to take the second electron out from this 2p, we need to supply lot of energy, right? Because over here, if you want to take second electron out, that second electron has to be taken from completely filled configuration, and in order to take the electron out from the completely filled configuration, you need to supply tremendous amount of energy, right? So the difference in the first and the second ionization energy is pretty much large in the alkali metals, right? So that's what I'll be checking over here. I'll be saying in which of the element the difference in the first and the second ionization energy is maximum. You can see in the option second, the difference between the first and the second ionization energy is maximum. That's why this second element, it must belong to the alkali metals, right? I'm sure it's clear to everyone. Okay? People, is it clear to everyone? Let me know in the chat box so that I can move on to the next one. Yes, Surya Lakshmi, you can do that. You have got some 20-25 more days, right? You can do that. Perfect. Arshad, I'm doing great. How are you? All right, people. Let's move on to one more question then. It was a very simple question, the conceptual one, right? Let's move on to one more. Okay, these are certain reactions given to me, right? Calcium phosphide is reacting with HCl. It's giving CaCl2 plus P. Then in the second reaction, P4 is reacting with NaOH and water, leads to the formation of Q and NaH2PO2, and PH4I reacting with KOH leads to the formation of Ki plus H2O plus R. I need to see what is this P, Q and R. These are again the memory based questions, people. These are the three reactions which have been directly taken from NCERT, and this is again your NTA question over here, right? Yes? Right? Yes, Deccan, you can do that. You can do that. You need to enroll into the crash course. Definitely you can do that. People, give it a try. It's a very simple question, guys. The direct question from your NCERT, and I'm sure you all must be remembering these reactions. Yes? Perfect. So people, it's a very, very simple question as I told you. See, we have got calcium phosphide. I'm making it react with HCl, right? It leads to the formation of CaCl2, and with this CaCl2 you'll be getting PH3 as well. You get phosphine as well over here, right? This is the common reaction which is given in your NCERT, right? Similarly, this is again the common reaction which is the example of the disproportionation reaction. We have studied this reaction in detail in the equivalent concept, if you remember. Yes, P4 plus 3 times NaOH plus 3 times H2O gives Q. What is this Q? This Q is again your PH3. This Q is again your PH3, right? Similarly, your PH4I on reaction with KOH, it gives what? It gives Ki, right? Apart from this Ki, it gives water as well. And apart from this water, it's again going to give PH3 over here. So in all the reactions, your P, Q and R, everywhere is your PH3, right? Okay, so remember this from now onwards. Okay? Yes, Dheeraj, you can go ahead with your doubt. What is your doubt all about? You can let me know in the chat box without spamming. Yes, Deccan Chronicle, you can do that. I'm telling you, yes. You need to enroll into the crash course batch as soon as possible. Yes, Chaitanya, I know Pahul, sir, absolutely. Okay, so let's move on. So what's going to be the answer of this question? It's again going to be option 2 only, right? Moving on to one more question, people. Match column 1 with column 2. You're supposed to match column 1 with column 2. Yes? Well, majority of the questions which I have come up with in the tonight's session are the memory-based questions directly taken from your NCERT, right? All these questions are NTA-based, and I'm sure you can clearly solve these, right? Someone is saying, sir, we cannot see the screen. Bro, I can see the screen. The screen is right in front of me, right? Give it a try, people. Let me know its answer fast. Let me know its answer fast. It's again a simple question. First of all, I need to match column 1 with column 2, right? State function. What is the state function, first of all? State function is the one which only depends on the initial and final state of the system, right? And which of the following is the state function among all? As you all must be knowing, entropy is the example of the state function. So first of all, you are going to match your P with 3. You are going to match P with 3. Point number 1. Yes? Okay. Now people, look at the last option, intensive property. Which of the following is intensive property? Specific heat capacity is the example of the intensive property. Specific heat capacity, right? It is the example of the intensive property. Okay. Now at the same time, as you all can see, this R, delta U is equal to Q. Well, as per your first law of thermodynamics, delta U is equal to Q plus W. Delta U can only be equal to Q if W value is 0. When can be W value is 0? If the process is isochoric. In case of isochoric process, what happens? Volume of the system is kept constant, right? So people, this option, I'll be directly relating with option 4, right? And what is left? Delta H is equal to Q. You are directly going to relate it with your option 1 over here. So which option satisfies it exactly? Which option satisfies it? Let me know first. You are going to match P with P, you are going to match with 3. P, you are going to match with 3. And Q, you are going to match with first. Q, you are matching with first. R, you are matching with fourth one. And S, you are matching with the second one, right? So option A is the one which is correct among all, right? Yes? Perfect. Exactly, people. So let's move on. Let's move on to one more question. Yeah? Let's move on to one more question. This is option A, the answer of this question. I'm sure it's clear to everyone, right? Moving on to one more. Select the correct options among all. Scandium tripositive, titanium tripositive, palladium dipositive, and copper dipositive ions. You need to see which one among the following is paramagnetic, which one among the following is diamagnetic, right? So people, I have told you in detail how do we check these sort of questions, right? See, I'm given with 4 ions. Any ion which will be having unpaired electron is supposed to be paramagnetic, and any ion which will be having paired electrons, right? That's supposed to be diamagnetic in nature, yeah? So basically among these 4 ions, you need to see which ion has got the unpaired electrons. Wherever there will be unpaired electrons, that is definitely going to be your paramagnetic, and wherever you see there will be paired electrons, right? That's absolutely going to be diamagnetic in nature. Well, I can see majority of the students are coming up with option D, yeah? So let's exactly get to know what the answer of this question is. Absolutely, it's option D. Well, people, if you can look at the options, see. If you look at the configuration of scandium tripositive, it contains 3d0 electrons. So there is no electron in this d subshell over here. So it's absolutely going to be diamagnetic. There is no electron in its d subshell over here, right? It's absolutely going to be diamagnetic. If you talk about Pi plus 4, again 3d0 configuration, again it's going to be diamagnetic. If you talk about PD plus 4, 4d8 configuration, there are 3 unpaired electrons, right? Similarly, Cu dipositive, 3d9 configuration, there are 4 unpaired electrons, and wherever you see unpaired electrons in some outermost subshells, that is something which we call as paramagnetic, right? That is supposed to be your paramagnetic, correct? Yes, I'm sure it's clear to everyone. A very, very simple question this was, right? So how do we solve these sort of questions? First of all, you'll be writing the outermost electronic configurations of your ions, and wherever you see the unpaired electrons, that's absolutely going to be paramagnetic, and wherever you see the paired electrons or empty subshell, right, you'll be calling that as the diamagnetic species, right? Perfect. Exactly, people, exactly. Let's move on to one more question. This is one more question. The wavelength of the third line of the Balmer series for the hydrogen atom is? Well, this is the question from the chapter Atomic Structure, and it's a very, very simple question. First of all, you all must be familiar with something called as Balmer series. When do we get the Balmer series? When the electron makes a transition from higher energy state to shell number 2, the series of lines which we get is something which we call as Balmer series, right? Yes. Balmer series, when do we get the Balmer series? When the electron makes a transition from higher energy state to shell number 2, right? Now people, have a look. Let's say this is your energy state 1, right? Let's assume this is your energy state 2. Let's assume this is your energy state 3. Let's assume this is the energy state 4. And let's assume this is the energy state 5, right? Okay. The electron has to make a transition from higher energy state to shell number 2, right? Okay. So electron has to make a transition from higher energy state to shell number 2. So electron has to reach finally here. Here the electron has to finally reach, yeah? Here the electron has to land finally, correct? Now first of all, understand. We need to calculate the wavelength of the third line of Balmer series. First of all, when the electron makes a transition from 3 to 2, this is what we call as first line of Balmer series. When the electron makes a transition from 4 to 2, it's what we call a second line of Balmer series. When the electron makes a transition from 5 to 2, it's something which we call as the third line of the Balmer series. So in the third line of the Balmer series, the electron is making a transition from shell number 5 to shell number 2. So electron is making a transition from shell number 5 to shell number 2. This is something which I got to know, correct? Now simply use the Rydberg's formula and kill the equation. It's a very simple one, right? What is my Rydberg's formula all about? I'll say 1 divided by lambda is equal to RH, right? R Z square, right? Z square. Since for hydrogen Z value is 1, 1 divided by N1 square, N1 ka square, 2 ka square is 4, minus 1 divided by N2 ka square, 5 ka square is 25, right? So you get something as 1 divided by lambda is equal to R. It's going to be 25 minus 4, that is 21, 21 divided by 100, right? Or you can say lambda is equal to 100 divided by 21R, right? So this is the lambda which I was supposed to calculate. This will be the wavelength emitted when the electron makes a transition from shell number 5 to shell number 2, or you can say this is the wavelength emitted in the third line of the Balmer series, right? I'm sure it's again clear to everyone, right? So which option satisfies it, people? Which option satisfies it? 100 divided by 21R, okay? Yes? Perfecto. Yes, Arshad, BitSat mock tests are over. Yes, now it's mains again, JEE Mains. Perfecto, and the ones who have just joined it, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, people, right? Okay, moving on to one more question. This is one more question. Mark the correct orders of the decreasing acidic strength of the following compounds. Again, the NTA question, I'm sure you can solve this clearly, right? So people, how do we solve these sort of questions? First of all, let me fix the reference. See, OH everywhere is common, so this OH is my reference over here. This OH is my reference, correct? Now, first of all, we have got no other group attached with this benzene ring apart from OH. Yes. Over here, we have got NO2 group attached. Right here, we have got OCH3. Right here, we have got NO2. Okay. Well, people, NO2 over here, it's attached at the para position, right? And at para position, NO2 operates minus M effect, right? See, this OCH3, it's attached at the meta position. It's attached at the meta position. And at meta position, this OCH3 operates minus I effect, right? If this OCH3 was attached at para position, then at that time it would have operated plus M effect, yes. But right now it's attached at meta position, so it's simply going to operate minus I, yeah. Now people, at the same time, if you look at this option, okay, over here nitro group is attached at the meta position, and at meta position it only shows minus I effect, right? And we all know it, acidic strength is directly proportional to minus effects. It's directly proportional to minus effects, and you all must be knowing minus M dominates over minus H, which dominates over minus I, right? See, in this case, we have got minus M, right? In this case, we have got minus M, right? So this is going to be maximum acidic among all. Second is going to be maximum acidic among all, right? Followed by, have a look. Over here minus I, over here minus I. But nitro shows stronger minus I, due to which this one is going to be more acidic. So fourth one is going to be more acidic, right? Then comes your third one, and at the end comes your first one. At the end comes your first one. This is going to be the order of the acidic strength. Is there any option satisfying it? It's 2, 4, 3, 1. 2, 4, 3, 1. 2, 4, 1, 3. 1 and 3. 1 and 3. No, this is completely wrong. See, this is wrong. This is not 2, 4, 1, 3. It must be 2, 4, 3, 1. Because over here it shows minus I because it's attached at the meta position, right? Okay, so 3 should be more acidic than that of first one, right? This could have been the answer. This could have been the answer when this OCH3 was attached at para position. This could have been the answer when this OCH3 was attached at the para position, so that it could have shown over there as the plus M effect, due to which it would have been the least acidic among all, right? Yes, this option is only possible when this OCH3 is attached at the para position, because at para position it will be operating plus M effect, okay? Right? So this is the correct order. No order among these is absolutely correct for the question given to us. The correct order is going to be this one, okay? Right? Perfect. So maybe by mistake, there might be a printing mistake. This OCH3 should have been over here, right? If the OCH3 would have been over here, then this would have been the correct answer, yeah? And I'm sure they would have given this as the correct answer, but it's not the correct one, right? Okay, I told you. Yes, so this would have been the answer if OCH3 would have been attached at the para position. As simple as that, yeah? Okay, for the gases CH4, CO2, O2 and H2, which gas will have highest value of A, lowest value of B? Again, the NTA question. That's great, Arshad. People, let me know its answer fast. Yes, Dev, you can expect these sort of questions, these types of questions, these patterns of questions in your coming JEE. Give it a try, people. Give it a try. Let me know fast its answer. It's again a very simple question. Understand. First of all, I need to see which gas has got the maximum value of A, right? A and B both are the van der Waals constants. And as you all must be knowing, A gives us the idea about the force of attraction between the gas molecules, right? Force of attraction between the gas molecules. And B gives me the idea about the size of the gas molecules, right? Size of the gas molecules, correct? Now people, have a look. First of all, this force of attraction, van der Waals force of attraction, van der Waals force of attraction. Remember, more the force of attraction, more the value of A. When can be the force of attraction between the gas molecules more? If the molar mass or molecular mass of the gas is high, that gas whose molecular mass will be high, whose size will be more, right? It will be having more force of attraction between its molecules, and for that gas, A value will be maximum. So first of all, check it out. Which gas has got the maximum value? Which gas has got the maximum molecular mass among all? It's absolutely going to be carbon dioxide, which has got the maximum molecular mass among all. So between carbon dioxide molecules, there will be maximum force of attraction. Maximum force of attraction means maximum value of A. So carbon dioxide is the one which will be having maximum value of A. Similarly, lowest value of B. Remember, more the value of B, more the size of the gas molecules. Lesser the value of B, lesser the size of the gas molecules, right? Which has got the least size among all? It's absolutely going to be H2. H2 has got the least size among all. If H2 has got the least size among all, that means its B value will be minimum, right? So option A is the one which is correct among all. Clear to everyone? It's absolutely, you all are perfectly right. It's going to be option A. Yeah? Right? Perfect. I'm sure it's clear to everyone. Let's move on to one more question then, right? Okay, the number of hyperconjugated structures shown by the carbocations as given below, which is not correctly matched. You need to see which one is not correctly matched. Have a look, guys. Understand. The first carbocation which is given to me, it's C positive. This is CH3, right? This is CH3 and this is CH3. Correct? See, first of all, this is the carbon carrying the positive charge. All the other carbons which are attached with this carbon, are what we call as alpha carbons. So this is the alpha carbon, this is the alpha carbon, this is the alpha carbon. So these are the alpha hydrogens. So right here, how many alpha hydrogens we have? We have got 9 alpha hydrogens, right? So first one is absolutely correct. There are 9 hyperconjugating structures. There are 9 alpha hydrogens. That means there are 9 hyperconjugating structures. If you look at the second one, right, this is the carbon carrying the positive charge. This is alpha carbon, this alpha carbon. These 3 are alpha hydrogens, these 3 are alpha hydrogens. So total 3 plus 3, 6 alpha hydrogens. Total 6 alpha hydrogens. But it's mentioned that it has got some 8 alpha hydrogens. So this one is incorrect, right? This one is incorrect. Similarly, over here, 3 alpha hydrogens. Over here, no alpha hydrogen at all. Correct? So which one is incorrect? Which one is incorrect? So option 2 is the one which is incorrect among all. So this is going to be our answer. So option 2 is going to be the answer of the question. I'm sure it must be clear to everyone, right? Exactly, people, it's option B. Yeah? A very simple and basic question. People, from these questions, you'll clearly get the idea of the level of JEE Mains examination, which is going to be held in your August. Because these are the NTA questions. I'm not selecting these questions from any sort of book or something. These are the NTA questions which are there on the NTA website, by means of which you'll get the clear-cut idea of what is going to be the level of your JEE Mains August attempt, right? Yes? Dev, 2 is incorrect. 2 is incorrect. It's not correct. Perfect. An electric charge of 5 farad is passed through 3 electrolytes, AgNO3, CuSO4 and FeCl3. The grams of each metal liberated at cathode will be. Okay, so we have got an electric charge of 5 farad. It's passed through 3 electrolytes, AgNO3, then CuSO4, then FeCl3. The grams of each metal liberated at cathode will be. First of all, if I do the electrolysis of AgNO3, at cathode, reduction takes place, okay? And currently I'm doing the electrolysis of AgNO3. At cathode, reduction takes place. Reduction means gain of electrons. So this is going to be the reaction which will be taking place at cathode. Then only your silver will be getting deposited, right? Now people, understand. I'll say the mass of silver deposited is equal to equivalent mass of silver multiplied by I multiplied by T. Instead of IT, I'm writing Q divided by 96500, right? So this is going to be equal to equivalent mass of Ag, which is going to be molar mass of Ag, 108 grams, divided by n factor of Ag. Calculate the n factor of Ag. N factor of Ag will be equal to number of moles of electrons exchanged divided by stoichiometry coefficient. So 1 divided by 1, that comes out to be 1. So its n factor is 1. In the denominator, you have got 96500, and in the numerator, you have got Q. Q is the charge, which is 5 farad. Just solve this. So this is 5 farad, so 5 multiplied by 96500, then only it will be in coulombs, okay? So solve it, people. Solve it. 96500, 96500 gets cancelled. So mass of silver deposited is going to be what? It's going to be 540 grams. So you got to know 540 grams of silver are being deposited, right? 540 grams of silver are being deposited. So option 2 or option 4, anyone can be the answer. Now let's check the second one, CuSO4. Let's try to do the electrolysis of CuSO4 now, right? And when we do the electrolysis of CuSO4, at cathode, copper gets deposited. So the reaction which takes place at cathode, it must be this one. Cu die positive plus 2 electrons gives Cu solid. So first thing, if I'll ask you, what is the n factor of this copper? You'll clearly say number of electrons exchanged, that's 2, divided by stoichiometry coefficient, that's 1. So 2 divided by 1 comes out to be 2 only, right? Yes. Now people, I'll simply say mass of copper deposited is equal to equivalent mass of copper multiplied by Q divided by 96500. Equivalent mass of copper, as you all must be knowing, it's molar mass of copper divided by n factor of copper. Q value is 96500 multiplied by 5. In the denominator, we have got 96500, correct? Now solve it, this and this get cancelled. Solve it, get the value of mass of silver deposited, right? So majority of the people are coming up with option D, so option D must be the answer. So 158.8 grams of copper have been deposited, and at the same time 93.3 grams of iron has been deposited when we do the electrolysis of FeCl3 solution, right? Let me know in the chat box if every single thing is clear till here, so that I can move on. People, the question was direct from your Faraday's first law, right? Or you can use Faraday's second law in this as well. Right? Perfecto. Yes? Okay, so let's move on to one more, people. Soaps do not work in hard water containing calcium and magnesium ions because theoretical questions from your NCERT. What is the reason for that? Soaps do not work in hard water containing calcium and magnesium ions. Why? What is the reason? What is the reason? Can you let me know? Can you read all the options and let me know? Can you let me know? Read all the options carefully, let me know. Direct question from your NCERT people, right? Soaps do not work in hard water containing calcium and magnesium ions because calcium ions and magnesium ions, they form what? They form insoluble calcium and magnesium salts in the form of scum, right? Option A is the absolutely correct answer of this question, right? Option A is absolutely the correct answer of this question, right? Soaps do not work in the hard water containing calcium and magnesium ions because calcium and magnesium ions, they form insoluble calcium and magnesium salts in the form of a scum, right? I'm sure you would have studied all this in detail, right? This is directly your NCERT based question, yeah? Exactly, people, right? Okay, I'm moving on to one more then. This is one more. Which of the following alkyl halide is hydrolyzed by Sn1 mechanism? Again, your NTA question. Give it a try. Again, a simpler one. I'm sure you can solve this one properly. Which of the following alkyl halide is hydrolyzed by Sn1 mechanism? Well, people, in case of your Sn1 mechanism, what is the first step which happens? In the Sn1 mechanism, first step is your ionization step, which leads to the formation of carbocation, right? So first of all, what you will see over here, you will see wherever carbocation gets stabilized the maximum, that only favors your Sn1 mechanism, right? Okay, so over here, if this chlorine leaves as Cl negative, there will be positive charge on this carbon. If this chlorine leaves as Cl negative, positive charge on this carbon. If this chlorine leaves, positive charge on this carbon. And if this chlorine leaves, positive charge on this carbon. So where will be the carbocation maximum stable? I'll say over here, carbocation is maximum stable because it's 3-degree carbocation, which is stabilized by 9 alpha hydrogens, right? Yes. So this alkyl halide is hydrolyzed by Sn1 mechanism, right? Okay, there'll be maximum tendency for this alkyl halide to get hydrolyzed through Sn1 mechanism. Because over here, which carbocation gets formed? It is going to be your 3-degree carbocation, which is highly stable, right? Perfect. So option D is the one which is correct among all. Okay, the pKa of acetic acid and pKb of NH4OH are 4.75 and 4.75 respectively. Find the pH of ammonium acetate solution. People, you can solve this question. Darshan, this is going to be your level of your mains examination, right? I know the level of NT equations is very low as compared to the past 6-7 year JEE questions, right? Okay, but this is going to be your actual level of your mains. So you need to have a clear view of the level of the examination, right? Yes, Nilavan, you can expect these as well. People, it's a simple question. See, understand. We have got something called as acetic acid, right? We have got acetic acid. And with this acetic acid, we have got NH4OH as well, right? We have got NH4OH as well, okay? Yes. So first of all, this is the weak acid and this is a weak base, correct? When they'll react, they will lead to the formation of a salt, and this is the salt of weak acid and weak base. This is the salt of weak acid and weak base. Basically, I'm going to do the hydrolysis of the salt of weak acid and weak base, right? How do we calculate the pH for the hydrolysis of salt of weak acid and weak base? As you all must be knowing, pH for the salt of, or the hydrolysis of the salt of weak acid and weak base, it's going to be 7 plus half of P of Ka minus P of Kb, right? This is the formula to calculate the pH, right? See, pK value is given, pKb is given, and both are equal, right? So this whole term becomes 0. So pH comes out to be simply 7. So 7 is going to be the answer of this question. Isn't it a very simple question, people, right? Isn't it a very simple question? Absolutely. Just remember this formula, but this formula I'll be using only during the hydrolysis of the salt of weak acid and weak base, right? And this is actually the salt of weak acid and weak base. That's why I use this relation over here, right? Perfect. Okay, moving on to one more. When a plot between log of k and 1 by t is plotted, we get the graph as below. What is the value of slope in the graph? Again, your NT equation. See guys, you can clearly solve this question as well. I'm sure about it, right? Let me know its answer fast. Let me know its answer fast, people. It's a very simpler one, yeah? Well, I can see majority of the people are coming up with minus EA divided by 2.303R. Let's exactly get to know. See guys, you know, as per your Arrhenius equation is concerned, K is equal to rate constant is equal to A e raised power minus AA divided by RT, right? Okay. Let me multiply throughout by ln. It becomes ln of K is equal to ln of A e raised power minus AA divided by RT, right? If I'll use the property of ln over here, it becomes ln of K is equal to ln of A minus EA divided by R multiplied by 1 by T, right? Yes, this is what I got. Now I'm plotting a curve between log of k versus 1 by t. Okay, so instead of ln of k, I'll be writing 2.303 log of k is equal to, instead of ln of a, I'll be writing 2.303 log of a, right, minus EA divided by R. This is going to be 1 divided by t. Just divide throughout by 2.303. If you divide throughout by 2.303, it becomes log of k is equal to log of a minus EA divided by 2.303R multiplied by 1 by t, correct? Now people have a look. I'm plotting log of k along y-axis. I'm plotting 1 by t along x-axis. So instead of log of k, I'll be writing y. Yes. Instead of 1 by t, I'll be writing x. So this whole term becomes your slope, right? So slope, as you can see clearly, it's equal to minus EA divided by 2.303R. So slope of this curve over here, we got to know simply as minus EA divided by 2.303R. Correct? This is the slope of the curve which I was supposed to calculate, right? So option B is the one which is the correct one among all. I'm sure it's again clear to everyone, right? Yes, let me know people in the chat box if it is clear so that I can move on to the next one. Okay, match column 1 with column 2, right? Again the NT equation. See what kind of simple question this is again, right? Well people, as you all must be knowing, the relation between delta H and delta U, we know delta H is equal to delta U plus delta NG/RT. This is the relation between delta H and delta U, correct? Yes. Now we will have a look. In the first reaction, let's try to calculate delta Ng. Delta Ng is basically, what is delta Ng all about? Delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants, right? So how many gaseous products we have? 2. How many gaseous reactants we have? 1 plus 1, 2. So 2 minus 2 is 0. So for the first reaction, delta Ng is 0. If delta Ng is 0, that means delta H is equal to delta U. So for the first reaction, delta H is equal to delta U. So first one, you are going to equate with this one, right? So P equate with 3. P you are going to equate with 3. So among first and second, there will be the correct answer, right? Among first and second. Now let's look at the second option, right? Let's look at the second option. The second reaction says PCl5 gas. It gives what? It gives PCl3 gas plus Cl2 gas, right? Let's try to calculate delta Ng for this. It's again number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactant, that's 1. The value comes out to be 1. Delta Ng is 1. If delta Ng is 1, that means delta H is equal to delta U plus RT. So for this one, delta H is equal to delta U plus RT. That means you're going to attach with 4, right? You're going to attach with 4. So option B is the one which is correct among all, right? Yes. Let me know fast in the chat box if it's clear, and the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. When is the next mock test of chemistry? Tomorrow. Tomorrow, guys, at the same time. Yeah? Perfect. Let's move on to one more then. Which of the following will have the highest dipole moment? See, guys, what kind of question this is, right? Close your eyes and answer this. First, which of the following will have the highest dipole moment? Gayatri, I'm better than before. See, BF2 is a linear molecule, its dipole moment is 0, right? BF3, triangular planar, its dipole moment is also 0. H2O will be having some dipole moment. All have 0 dipole moments, right? So which one has got the highest dipole moment? It's absolutely going to be water, right? Among these 3, water is the only one which has got the dipole moment. In the first 2, the net dipole moments are 0. In the first 2 molecules, the net dipole moments are 0. So option C is the one which is correct among all, right? Yes, exactly. Okay, the freezing point of a 1 molar NaCl solution, assuming NaCl to be 100% dissociated in water, is. Okay, what do we are supposed to calculate? We are supposed to calculate the freezing point of a 1 molar NaCl, assuming NaCl to be 100% dissociated, right? If NaCl is 100% dissociated into its ions, Na positive plus Cl negative, that clearly says alpha value is equal to 1. And in case of dissociation, how do we calculate Van 't Hoff factor? 1 plus n minus 1 into alpha, right? So I value is simply going to be 1 plus n value. See, from 1 particle, I'm getting 1 plus 1, 2 particles, right? N value gives you the number of particles which you get from 1 particle over here. So from 1 particle, I'm getting 2 particles, so n value is 2 minus 1 multiplied by 1, right? So the I value comes out to be simply 2. We knew it, okay? Now, depression freezing point, delta Tf is equal to I multiplied by Kf multiplied by molality, right? What is delta Tf? Depression in freezing point. It's going to be freezing point of your solvent minus freezing point of the solution is equal to Van 't Hoff factor I multiplied by Kf multiplied by molality. Now put the values. A freezing point of 1 molar NaCl solution is this one. Okay, solvent which you are using over here, that's water, and freezing point of water, as you all must be knowing, that's 0 degrees centigrade, right? Minus freezing point of this solution, I need to calculate, right? I value, we know that is 2. Kf value is given to us as 1.86. Molality is given to us as 1, right? So from here, you'll be getting the freezing point of the solution as minus times 3.72 degrees centigrade. This will be the freezing point of the solution. So option 2 is the one which is correct among all. A very, very simple question, people, right? Yes. So remember, in case of your 100% dissociation, I value is always equal to n, right? You all must be knowing this as well. In case of your dissociation, in case of a complete 100% dissociation, Van 't Hoff factor is always equal to the value of n. That's something which you all must be knowing, right? Perfect. Let's move on to one more question, people. Among the following molecules, SO2, SO4, ClF3, BrF5 and XeO4, which of the following shapes do not describe any of the molecules mentioned? Which of the following shapes do not describe any of the molecule mentioned? See guys, if you talk about SO2, there are 2 sigma bonds, right? How many lone pairs on sulfur? There is 1 lone pair on sulfur. So 2 plus 1 is 3. Steric number is 3, right? Steric number is 3, correct? 2 sigma bonds, 1 lone pair. What is hybridization? Hybridization is sp2. Okay, what is going to be the shape of it? 2 sigma bonds, 1 lone pair, right? It's going to be bent, right? It's going to be bent. Okay. Similarly, SF4, 4 sigma bonds, 1 lone pair on sulfur. So the shape is going to be seesaw. It's going to be a seesaw shape, right? Okay. Similarly, or you can calculate hybridization as well. 4 plus 1, 5. Steric number is 5. That means sp3d hybridization, right? Similarly, ClF3, right? In case of ClF3, how many sigma bonds we have? We have got 3 sigma bonds. How many lone pairs are there on chlorine? 2 lone pairs on chlorine, right? 3 sigma, 2 lone pairs, right? Hybridization is again going to be 3 plus 2, 5. That means sp3d. If I ask about the shape of it, what is going to be the shape? Shape is going to be T. This is a T-shaped molecule. Similarly, BRF5. In case of BRF5, there are 5 sigma bonds and there is 1 lone pair on bromine. So 5 plus 1. 5 plus 1, 6. So hybridization is going to be sp3d2, right? What is going to be the shape? 5 sigma bonds, 1 lone pair, right? 5 sigma bonds, 1 lone pair. It's going to be it's going to be square pyramidal. It's going to be square pyramidal, right? Its shape is going to be square pyramidal, correct? And similarly, if you talk about XCF4, in case of XCF4, there are 4 sigma bonds and 2 lone pairs on xenon. So it's going to be square planar in shape, square planar, and its hybridization is going to be again sp3d2, right? Square planar, right? See, first option is bent. Bent is mentioned over here. Seesaw, we have got 1 molecule with seesaw shape as well. T-shape, we have got 1 molecule with T-shape as well. Is any molecule having trigonal bipyramidal shape? Is any molecule having trigonal bipyramidal shape, people? No molecule among them is having trigonal bipyramidal shape. So this is the odd one out, right? So option 2 is the one which is the correct answer of this question, right? Yes, I'm sure it's clear to everyone again. Yeah? I'm sure it's clear to everyone, right? Where is IF7? Is IF7 given? IF7 is not given, right? Why are you asking about IF7? What is special in that? In case of IF7, it's going to be sp3d3, right? Yes, sp3d3 hybridization. Okay, let's move on, people, to one more question then. This question you can solve on your own, right? The correct order of relative degree of hydration. Degree of hydration. Degree of hydration. Well, people, if you talk about degree of hydration, or if you talk about hydration energy, that is directly proportional to the charge on cation and inversely proportional to its size, right? See, the charge everywhere is same. Now look at the size. Lithium has got the minimum size. If lithium has got the minimum size, so degree of hydrolysis in lithium is going to be maximum. So degree of hydrolysis in lithium is going to be maximum, followed by sodium, followed by this, all right? Option 2 is the one which is correct among all, right? Yes, perfect. Very simple question again, right? Okay, moving on to one more, people. Which of the following oxo acid of sulfur has OO bond? OO bond. Well, I can see there is Marshall's acid, H2S2O8. This is the structure of H2S2O8, if you remember. This is the structure of your Marshall's acid. And in case of your Marshall's acid, which of the following oxo acid of sulfur has OO single bond? We have got OO single bond in the middle. So this is going to be the answer of the question, right? Marshall's acid is the one in which we have got O single bond, O in the middle, right? Rest, in all the other cases, there is no O single bond O. There is no O single bond O in all the other cases. If you want to look at this, their structures as well, you can have a look. These are the structures which I was given with, right? There is only one option, right, which is Marshall's acid, or you call it as peroxo disulfuric acid, H2S2O8, where there is oxygen single bond oxygen, where there is a peroxide linkage between 2 oxygen atoms, right? Yes? Exactly, people. Exactly, right? Okay, let's move on to one more then. Okay, the half-life decay. Okay, the half-life for the decay of radioactive carbon is 5730 years. An archaeological artifact containing wood has only 80% of C14 activity as found in the living trees. The age of the artifact would be. Again, a very, very simple question, people, right? I'm not going to complicate it. See, we know radioactivity, it's a first order kinetics, right? Radioactivity, it follows the first order kinetics, yeah? All of you must be knowing it. Well, Music Stories is saying it is the NCERT equation. Is that? Is it the NCERT equation, right? It is the NT equation as well, okay? See, guys, see, first of all, this is your first order reaction. It is your first order reaction. Let's say this reaction represents your radioactive decay of your C14. Let's assume this is your C14. Let's say this A is your C14, right? See, guys, the first thing, if it is following the first order kinetics, right? Its half-life is 5730. T half for the first order reaction is equal to 0.693 divided by K. From here, can I get the rate constant? It's going to be 0.693 divided by T half. T half is 5730 years. I'm not going to do this calculation. You guys are going to do its calculation, right? Do its calculation till then, right? K value I got, right? Now people have a look. Let's say at time t is equal to 0, the initial amount of reactant is A0. At some time t, which is something I need to calculate, at some time t, the amount of A left is 80% of initial amount. So 80% of initial amount is left after time t. 80% of initial amount is left after time t. And the amount of reactant left after a given time, that's represented by AT. So AT is simply going to be 0.8 A0, right? So you got to know AT is equal to 0.8 A0, as simple as that, right? Yes? Now the question is done and dusted. Use the first order kinetics. K is equal to, or I'll be writing T is equal to 2.303 divided by K, where K you would have calculated from here, right? Log of A0 divided by AT. Instead of AT, what do I write? Instead of AT, I'll be writing 0.8 A0. It is 0.8 A0, A0 cancel, right? So it's going to be 10 divided by 8. It's going to be 10 divided by 8. People, K value you would have got from here by solving this. Just put the values into this equation, get the value of T, and whatever is the value of T, that is going to be your answer exactly, right? Yes? Right, people? K is equal to 1.209. How come K will be 1.209? It's a very simple question, right? I just use the first order kinetics, that's it. K is equal to 0.693 divided by T half. T half is 5730. So how come it will come out to be 1 point something? So exactly, let me show you its answer. See, guys. K value you are getting from here like this, right? Then you use the integrated rate equation, correct? After using the integrated rate equation, you are getting finally the answer as 1845 years, right? Yes? Right, perfect. Exactly. Let's move on to one more, guys. How many minimum steps, in how many minimum steps you will convert 4 nitrotoluene into 2 bromobenzoic acid, okay? So in how many steps you are going to convert 4 nitrotoluene? This is basically your 4 nitrotoluene, right? This is CH3, this is NO2, correct? So from this 4 nitrotoluene, what do I need to get? I need to get 2 bromobenzoic acid, right? I need to get finally 2 bromobenzoic acid. This is your COH. It is 2 bromobenzoic acid. So from here, I will have to reach here, right? In how many minimum steps it will be done? Someone is saying in 1 step. No, it cannot be done in 1 step. It is bromo, right? It is bromo. So first of all, you will do the bromination, right? First thing, you will use Br2 in presence of your CS2, right? What will happen due to that? Your bromine will get attached at the ortho position over here, right? Because this para, it's already occupied. So bromine is going to get attached at the ortho position. So in my first step, I used Br2 in presence of CS2. I did some bromination over here, right? So what do I get in this case? This is CH3, and this bromine gets attached at the ortho position because your NO2 is already over here, right? Okay, this is my first step, correct? Correct, people? Now what about my second step? Second step is I'll be doing the reduction of this nitro group, right? How do I do the reduction of nitro group? What should I use? Let me know fast. How do I do the reduction of it? I'll be using tin in presence of HCl, right? it is going to reduce this NO2 into NH2, right? So what do I get? What do I get in this case? This is your Br, this is your CH3, and over here what you'll be getting NH2, correct? So how many steps done till now? First step, second step, 2 steps done. Now people, what is going to be your next step? Now I'm going to convert it into diazonium chloride, right? So now this reaction will be undergoing diazotization, right? Diazotization. So what do I get over here? I get something like this. This is CH3, this is your Br. Instead of NH2, I'll be using N2Cl, right? This is what I call as diazotization reaction, okay? Now after diazotization, NaNO2HCl, right? NaNO2HCl, right? Okay. After this diazotization, what do I need to do? I need to remove this N2Cl from here. How do I remove N2Cl from here? Which reagent should I use? Absolutely, you people are right. I'll be now using H3PO2, right? H3PO2 I'll be using, right? Okay, if I'll use H3PO2, this N2Cl will get removed. So what do I get as the product over here? I get something like this. This is your CH3 and this is your Br, right? Now people, what do I need to get finally? I need to get 2-bromobenzoic acid. So instead of this CH3, I should have COOH. So what is something which I'll be using? I'll be using strong oxidizing agent KMnO4, right? So this strong oxidizing agent KMnO4, it's going to convert your CH3 into COOH, and over here already there was Br. This is what I call as 2-bromobenzoic acid, right? So from your 4-nitrotoluene, you got 2-bromobenzoic acid in how many steps? This is the first step, second step, third, fourth, fifth. So total, I did some 5 steps in order to convert your 4-nitrotoluene into your 2-bromobenzoic acid, right? So total 5 steps were done, correct? So the answer is going to be 5 exactly. Yes, people, exactly the answer is going to be 5, right? Yes, exactly the answer is going to be 5, yeah? Okay, clear? This is something which I've shown you in detail, yeah? Perfecto. Okay, in your caprolactam, if A is the number of lone pairs of electrons and B is the number of sp3 hybridized atoms, the value of A plus B is, give it a try. Give it a try, people, let me know its answer fast. That's great, Triambak. Okay, if you guys do not remember the structure of caprolactam, please remember it from now onwards. This is the structure of your caprolactam, right? What do I need to identify in this? I need to identify the number of lone pairs. Say, on nitrogen you have got 1 lone pair. On this oxygen you have got 2 lone pairs. Rest everywhere there is no lone pair, right? So how many lone pairs in total? There are 3 lone pairs in total. 2 plus 1, 3, right? Apart from this, I need to see how many atoms are there which are sp3 hybridized. Say guys, 1, 2, 3, 4. So this sp3, correct? This again sp3 because it's forming 4 bonds. This sp3, this sp3, this sp3, this sp3. But this one, this carbon, 1, 2 and 3. 3 sigma only, this is sp2. So how many atoms do we have right here? sp3 hybridized. sp3 hybridized. Look at it. How many? 1, 2, 3, 4, 5, 6, right? So 3 plus 6 comes out to be 9. So 9 is going to be the answer of the question, right? People, do remember the structure because in all the shifts, whatever shifts happened till now for your JEE this year, nowhere this question was asked, right? So have a look on this one as well, right? Okay. Let's see if we have more questions. Yes, we have got one more question, people. It's again a very, very simple one, I must say. HX is a weak acid. HX is a weak acid, right? HX is a weak acid, correct? Its Ka, ionization constant, is 10 raised to the power minus 5, right? It forms a salt NaX, right? It forms a salt NaX. If you look at NaX, right? NaX contains Na positive, X negative. Can I say this Na positive would have come from NaOH and this X negative would have come from this HX? As you all must be knowing, this HX is a weak acid, it's given in the question, and it's a strong base, right? So basically, this is the salt of weak acid and strong base. Basically, this is the salt of weak acid and strong base, right? Basically, this is the salt of weak acid and strong base, correct? When we do the hydrolysis of the salt of weak acid and strong base, how do I calculate degree of hydrolysis H? It's going to be equal to under root of KH divided by C, right? And it's going to be equal to, so, or let me write the formula finally. It's going to be under root of KW divided by Ka multiplied by C, right? Where Kw is the ionic product of water, Ka is the dissociation constant of the weak acid, C is the concentration of salt, right? It's going to be under root of Kw at 25 degrees centigrade is 10 raised power minus 14, ionic product of water. Ka, dissociation constant of weak acid, it's given to me as 10 raised power minus 5. C is the concentration of the salt. Concentration of salt is given to me as 0.1 molar, it's 10 raised power minus 1, right? So the value will be under root of 10 raised power minus 14 divided by 10 raised power minus 6, right? Can you solve it from here? Okay, so you'll be getting the value of H. This is what we call as degree of hydrolysis. But what do I need to calculate? I need to calculate percentage hydrolysis. If this is the degree of hydrolysis, then percentage hydrolysis is simply going to be H multiplied by 100, right? Once you get H from here, multiply that by 100. That's going to be your answer. Let me show it exactly. See, H value you got to know as 10 raised power minus 4. 10 raised power minus 4 multiplied by 100. So percentage hydrolysis is going to be 0.01% over here, right? Yes, is it clear? Is it clear, people? It was again a simple question, but a little bit of calculation was involved. That's it. Okay, this question you can solve on your own. You can let me know. You can let me know, people, fast. Let me know the answer of this question. Okay, see guys, understand properly. First of all, it's a bidentate ligand, right? It is the unidentate ligand, right? How many bidentate ligands we have? 2. So how many coordinate bonds? See, one oxalate ion forms 2 coordinate bonds. So 2 oxalate ions forms total 4 coordinate bonds. One water molecule forms 1 coordinate bond. 2 water molecules will form 2 coordinate bonds. So total how many coordinate bonds are being formed with this central metal ion? Right? 4 plus 6. So 6 is the coordination number. 6 is the coordination number. First step is done, right? Water is the weak ligand. Water is the weak ligand, right? Water is the, sorry, I've got nothing to do with weak field or strong field. This water is a neutral ligand. This is the negatively charged ligand, right? This is the negatively charged ligand, correct? One oxalate ion contains minus 2 charge. So 2 oxalate ions will contain minus 4 charge, right? In order to neutralize it, this should have plus 4 over here, right? Is that? Oh, sorry. Okay, there is K4 also. Sorry. See, this is your, see, do it like this. Potassium shows plus 1 oxygen state multiplied by 4 potassium atoms. Its oxidation state, let's assume as X. Oxidation state of oxalate is, charge on oxalate is minus 2, and how many oxalate ions we have? 2. This is neutral. This term is going to be 0, right? So what is going to be the value of X? Value of X is coming out to be 4. Sorry, value of X is coming out to be 0, right? Yes? So it's going to be 6 only. 0 is the oxygen state, so I must say 6 is going to be the, how come it's 8, guys? How come it's 8? This is 4. 4 minus 4 is cancelled out, right? Y is 0. It's showing Y is equal to plus 2. How come? How come Y is plus 2? Is there some other thing attached inside? See, coordination number is to 6. We know that, right? He is showing Y is equal to, the charge is plus 2. Is the charge plus 2? Okay. There might be a mistake in the equation. The answer of this question is going to be 6 only, right? 6 plus 0. Yeah? All right. Okay, how many of these compounds are aromatic? How many of these compounds are aromatic? See, first of all, if you look at the first ring, it's a cyclic part, it's a cyclic ring. Every carbon is sp2 hybridized. Every carbon is sp2. There are 2 pi electrons involved in the complete cyclic conjugation. 2 pi electrons are involved in complete cyclic conjugation following the 𝐓𝐞𝐬𝐭 rule. So this is aromatic, right? So 2 to 4, right? 2 to 4, 4 pi electrons. So this anti-aromatic, right? See, 2, 4, 6, right? 6 pi electrons, this aromatic, right? 2, 4, 6, 6 pi electrons, this is aromatic, right? 2, 4, 6. 6 pi electrons, this is aromatic, right? 2, 4. 4 pi electrons, this is anti-aromatic, right? Only 2 pi electrons, this is aromatic, right? So how many aromatic molecules we have? 1, 2, 3, 4, and 5. So out of all these molecules, there are 5 molecules which are basically aromatic, right? Yes, exactly, people, you all are perfectly right. Exactly, it's 5. 5 is the answer, yeah? Okay, let's see if we have more questions. No, people, this was the last question, right? I'm sure you would have enjoyed the session, yeah? Yes, exactly, Udaya, high 5, yeah? And the ones who have not joined in the crash course yet, well, people, do get enrolled in this as soon as possible. A lot of you guys have already joined it, that's great, right? And a few more, a lot of you guys have not joined in the crash course yet, so do join in as soon as possible, because these 20 days, trust me, these are going to decide your entire future, right? So do study hard properly in these 20 days, right, till your JEE Main's next attempt, right? And the best way to plan these 20 days is to get enrolled in the crash course for the JEE 2021. So do get enrolled in this. This crash course is going to be held on the actual Vedantu platform, right? Okay, and it's not only for the chemistry. All the 3 subjects are covered in this crash course, right? Physics, chemistry, as well as mathematics. Everything is clear. Everything is involved over here. It's not only about the syllabus completion. There is mock test. There'll be test series. Every single thing is included in this, right? And people, at the same time, let me show you exactly how to get enrolled in this one. See, guys, first of all, do get enrolled in it as soon as possible. Trust me, it is going to be highly, highly, highly beneficial for you guys, okay? So how to get enrolled in this one? See, this is the video which you guys are currently watching, yeah? This is the video which you guys are currently watching. You just need to drag this video a little down, click on this show more. After clicking on this show more, you'll be getting a lot of links. If you want KVPY SX crash course, you can click on this link. If you want JEE crash course, you can click on this link. After clicking on this link, see, physics, chemistry, mathematics, right? Okay, so you need to use this coupon code WSCC and click on buy now. You'll be getting some. You'll be, yes, so there, it's absolutely amazing, right? I told you, crash course is absolutely amazing. I hope you're loving it. Yes? Right? No, Gayatri, tomorrow GOC top-notch questions won't be there. Day after tomorrow it will be there, right? Day after tomorrow, GOC top-notch questions will be there on the Neatly channel, right? Okay, so people, hello Harsha, how are you? So people, with this our today's session is done, right? There is one more link in the description. Do click on this link as well. This is for the Telegram. Do click on this link, get added to the Telegram group and stay updated about the classes, right? And at the end, the ones who have not liked the video, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? So tomorrow there'll be one more mock test at 10:30 p.m. in the night. Okay, I'll see you guys tomorrow again. But people, do not forget to get enrolled in the crash course, which is going to be highly beneficial for you, right? So take care. I'll see you guys tomorrow at 10:30 again. Till then, you take care. Good night. Bye-bye.